One way that you can use dynamic SQL is to overcome some of the limitations of the pivot statement. Now, when you're learning and using the pivot operator, you might try to write code like this. Rather than hard coding the list of customers, for example, you might try to include a select statement here within the in clause. And you already have a hint that something's not right because of the red squigglies. IntelliSense is seeing that something's wrong, and in fact the problem is incorrect syntax near select. Not exactly the most illuminating message, but it indicates that there's a problem. And if I try to execute this, if I missed that IntelliSense hint, I can run it and I get 2 error messages. Okay, so there's a problem with this. This just doesn't work. Because one of the limitations of the pivot operator is that you have to hard code that list of columns within the in clause. And in this particular case, SQL Server explicitly doesn't support the use of a subquery in the in clause, which is what I'm attempting to do here. Okay, and this is an example where the problem's a bit more fundamental than a mere syntax errors, although that's the manifestation of the errors that you get. So in a pivot, you have to use hard-coded values in that in statement. And that's a serious limitation if you want to write a query that automatically shows all values, particularly in a table where you're adding companies and adding sales over time. Or if you want to only list certain values that meet some kind of criteria. So one way to overcome this limitation is by building the pivot statement dynamically. And that's what this next set of code does. So this is a complete batch that does precisely that. So the code starts by declaring a companies variable and a SQL variable. Companies is going to hold a comma-delimited list of all of the companies that I'm going to include in the results. And then SQL is going to hold the SQL string that I want to execute dynamically, because I'm going to generate not a statement like this, but a string that's a statement like that, that includes a comma delimited list of companies there. Okay, so those 2 variables hold those values. The next part of the code then builds that companies variable. And so what it does is it's using a subquery here to select the distinct company names from the customer orders by year view. And then it concatenates all that together. So it's assigning the value to companies, and it's concatenating each distinct company name onto companies along with a comma. So this is the code that generates that comma delimited list of companies. Okay, and then this step removes that leading comma, just uses the stuff function to stuff essentially a nothing into that leading position to get rid of the leading comma there. And then the code prints out the companies. It displays it in the output window. All right, so now it's time to build the dynamic pivot statement. So this uses that SQL variable, and it's going to do a select star from customer orders by year. So I'm basically just mimicking this statement here and putting in the comma delimited list of companies right there. So concatenating on pivot, some amount for company name in, and then I'm concatenating that list of companies right there and as P. All right, so at this point, that SQL variable has that complete string that consists of the select statement that I want to execute. All right, then finally, the code uses the SP execute SQL system sort procedure in order to execute that code. So I'll go ahead and execute this batch. Oops. Right there. Execute that. And there you have the results. So I have the order years, and it's been pivoted on the company name. And so we have all the list of companies. So you can scroll out here. Kind of unwieldy results, but it shows that you can in fact create a dynamic pivot, although it requires using a dynamic SQL to do that. Then if I go over here to the messages pane, you can see that comma delimited list of companies. Again, this is where I use that print statement in order to print that string. And you can see it's just a comma delimited list of companies. that gets inserted as the value for that in clause within the dynamic SQL statement. So until Microsoft adds the ability to use a subquery to generate the values of an in clause in a pivot operator, this dynamic SQL technique can help you build more flexible queries. Although you don't always need to use embedded parameters with SP-execute SQL, as in the example I just showed you of dynamically generating a pivot query, the real power of SP-execute SQL becomes apparent when you do want to embed parameters. You can then use additional arguments when calling the system stored procedure to execute dynamic SQL in order to specify the names, data types, and values of the embedded parameters. Now I'm going to show you an example of a stored procedure that allows a user to pass in a customer ID or a city or both. To keep the example simple, the procedure is going to support only 2 optional parameters, but in a real-world application, you could support many more. Then, based on the values that are passed into the procedure, it dynamically builds and executes a SQL statement, embedding the necessary parameters when it executes that statement. This code builds this proc get customers. All right, so as I mentioned, there's a parameter customer ID. It's an nchar5, and it has a default value of null. And then the second parameter is a city parameter. It's an nvarchar15, and these data types mirror the data types for equivalent fields within the Northwind database. And city also has a default value of null. This debug parameter lets you specify whether you want to print out the SQL statement. And you can use that for debugging purposes before executing the code. All right, so then the body of the stored procedure once again declares a SQL string. Nothing magic about the name, it's just a variable name to hold the SQL statement that I want to execute. And then I set the value of that variable to select star from customers, where 1 equals 1. I'll talk about that in just a second. And then, for the case when customer ID is not null, it concatenates on a matching predicate here for customer ID equal to the customer ID value that was passed in to the stored procedure. Now, within this statement, I'm calling that parameter a different name. Okay? And I'll talk more about that in just a second when we look at executing that code. Okay, otherwise it concatenates on this empty string. If the city is not null, then it does the same thing. It adds another AND clause in order to filter by city. Otherwise, it concatenates on an empty string. Now that's where this where 1 equals 1 comes into play. Without doing this, the code would be a little bit more complex because I would have to handle the case where there's no where clause. And I'd probably do that by just having set SQL equals to that, and then having a separate statement that then tests to see if both customer and ID and city are null or not null, and then having additional logic for generating a dynamic where clause. And then I'd concatenate that onto the SQL parameter as well. But in this case, if both customer ID and city are null, then the predicate is just where 1 equals 1, which is the same essentially as not having a where clause at all. So it just simplifies this code, and there's lots of different ways of doing that. Okay, then this code uses that if debug equals 1 in order to print SQL. So if I pass in a 1 for debug or print it, the default is to not print that statement. So this is an optional parameter as well. Okay, so here's the call to SP-execute SQL. The required parameter is the SQL that I want to execute. Not much purpose in calling the stored procedure if there's no code that I want to execute. And then it includes information about the parameters that I'm passing. So I pass in a string that specifies that I'm going to include customer ID as nchar5. So that matches up with the name of the parameter right there. And city, that matches up the parameter right there. And then this code then assigns the value from customer ID, the parameter passed into the stored procedure, and assigns it to cust ID. So this is the code that actually passes the parameter value from what was passed into the stored procedure into the parameter that is defined within the dynamic SQL statement. So the syntax here is a little bit funky, particularly because you have to supply a string and then essentially assignment operators there. But this is the code that links the parameter values here passed into the stored procedure to the parameter values within the dynamic SQL statement. And if you have more parameters, you just add to this comma delimited list of parameters along with their data types. Okay, I'll create this stored procedure and then execute it twice. Once, I'm supplying the city of Paris, and in both cases, I'm using debug equals 1, so we'll see the print statement. And for the second one, I'm just specifying the customer ID value. I'll execute both those together, and there you have the result. There's our Paris customers. This is the primary key, so we're only going to get one row here, and so this is the one with the customer ID of alpha key. And if we go over here to messages, you can see the dynamic SQL statements that were generated. First was select star from dbo.customers, where 1 equals 1 and city equals city. And then select star from dbo customers, where 1 equals 1 and customer ID equals customer ID. Quote name is a built-in T-SQL function that's designed to help you construct dynamic SQL statements. The default behavior of quote name is to add square brackets around a string that you pass to the function. This is useful when you're building SQL strings that contain unknown object names that might include illegal characters, such as spaces. Here's an example of some code that uses quote name. The idea here is this is code within a stored procedure that lets the user pass in a schema name and a table name, and the stored procedure, or in the code in this case, would return the count of rows from that table. Okay, so I'm declaring a schema and a table. So the idea is that these would be parameters to a stored procedure. And then this, once again, is the variable that's going to hold the dynamic SQL statement. So instead of embedding this within a stored procedure, I'm just setting the value of schema and table to DBO and order details. Order details is a problem because it has this space here. That's not a valid character within a SQL identifier. But if I put it in square brackets, no problem, I can use it. So here's the SQL statement that I generate. SQL count star from, and then I concatenate in that schema name, but I run it through the quote name function in order to put square brackets around it. And then I concatenate a period, and then table, which I also run through quote name to put square brackets around that. In this case, square brackets are only required for the table name, but I really don't know what the user might pass in as a schema name. Then I print the SQL statement and execute it. Execute that code. So as you can see, there's 2,155 rows in that order details table. And if I look over here at messages, I can see that it generated this select count star from dbo.orderDetails. And quote name put these square brackets around those names. All right, so that's useful. But quote name is most useful for preventing SQL injection attacks, which should always be a concern when you're executing dynamic SQL with values that users pass into an application. You can use embedded parameters for user-supplied values as a reliable way to prevent SQL injection attacks. However, sometimes you may want users to be able to pick object names, which can't be obtained in embedded parameters in your SQL statement. Parameters can only be used for data values. Okay, so this next code demonstrates a SQL injection attack. So it's similar to this previous example, but now what it's doing is for the table variable, it's simulating a user passing in this string. So really they should only be able to pass in this, but they've added this semicolon and are doing a select star from employees. And this is really dangerous because that employees table could have sensitive data. It could have social security numbers, it could have home addresses, it could have plenty of information for stealing identities. Okay, so this is not a good thing. All right, so it's the same code as before. It's select count star from schema and table. And notice that I'm not using quote name, so I'm just outputting this raw data. And then I print out the SQL and execute the code. And now when I run this code, I get both the number of rows in the table as well as all of the data from the employees data table. So as you can see, it has birth date, might have salary information, and so forth. Okay, so not a good thing. Now, if you go over here to messages, you can see the actual code that was executed. So this is the overall dynamic SQL statement that was generated in this step right here. So it has select count star from DBO orders. So that's fine so far. But then it has the semicolon and select star from employees. So that's the basic of SQL injection. And it also indicates just how easy it is to do this. Now, select star from employees is not good, but it can even get worse. Maybe instead of a select statement, the attacker includes a drop table or drop database statement. And if this code is executing with the necessary permissions, that code will execute and your database is history. Okay, so you can use quote name to protect against this kind of SQL injection attack. So the only change here is that I've changed this in order to run it through quote name, both the schema and the table name. And so now when I execute this, I get an error. I don't get any results at all. Because look at the select statement. So it selects star from, or count of star, from a table called that. So this is an invalid object name. There's no table called that. There can't be a table called that. Okay? So quote name is putting quotes around all of that so that SQL Server looks for a table with that name and doesn't find it. And gets an error instead of returning any information whatsoever. All right, now, quote name by default adds square brackets around text, but you can specify that it should add quote marks instead by using an optional second parameter. And that's what this code does here. So this is going to put quotes around whatever is within parameter here. Now, I want to put single quotes around it, and because single quote is the string delimiter within Transact SQL code, I need to double them up. And so this is the equivalent of just doing apostrophe, apostrophe, or single quote, single quote. Okay, so what the code does is it defines this parameter, varchar 50, and puts in O'Reilly. And even within this string, it has to double up the apostrophe. Okay, so a lot of apostrophes, but you can run this, and you can see the results. So this is just printing the raw parameter, and then this is printing that raw parameter value after you run it through the quote name. And notice that because I'm adding quotes to this, it automatically doubles up the apostrophes there within. Otherwise, this wouldn't be a valid string. In versions of SQL Server before 2008, there was a security problem with using SP-execute SQL in a stored procedure. Users who called the procedure needed to have permissions on the underlying objects that SP-execute SQL called, in addition to having execute permissions on the stored procedure. For example, if you used SP-execute SQL in a stored procedure to construct and execute a SQL string to retrieve data from the orders table, then users needed select permissions on the orders table in addition to execute permissions on the stored procedure. This was a problem because database administrators often want to deny permissions on tables and to grant permissions only on the stored procedures. Starting in SQL Server 2008, you can work around this in two ways. You can use execute as in the stored procedure to specify that the code, including any calls to SP-execute SQL, should execute with the security permissions of the owner of the stored procedure, or of the user who created the stored procedure, or of any named user. The second technique for defining a security context for code execution is to use a certificate. You can create a secure, encrypted certificate, and you can associate a user with the certificate. This is a special type of user that isn't associated with a login. You assign permissions to the user, and then sign a stored procedure with the certificate. The stored procedure then runs with the security permissions of the user who's associated with that certificate. Here's some code that demonstrates how to use this technique. I'm going to do all of this within a TestDB database. So I'm going to create a database, create a login called TestLogin with a reasonably secure password, and then I'm going to change the database context to TestDB. Okay, so this is just setup stuff. All right, then I'm also going to create a user called TestLogin. Okay, so it's going to be associated with the login, TestLogin. And now I'm going to create a test table and insert a row. So I just need an object that a user needs to have permissions to access. So it's just a very simple table test. Column 1 is not null, column 2 both integers and not null, and then insert a couple of values. So it's just a table with a little bit of data. Okay. All right, so now I'm going to create 2 test stored procedures. And in both, I'm going to execute some dynamic SQL. It really isn't dynamic because I'm not concatenating a string, but because I'm executing it using this SP-execute SQL system stored procedure, then it is in fact dynamic SQL. Okay? So this is a procedure that I'm going to create that is unsigned. And it's just going to select the data from that test table. And then this is an identical stored procedure, different name, proc to sign, but this is a stored procedure that I'm going to assign the certificate to. Okay, so I'll go ahead and execute that code, and now we have those 2 stored procedures in here in the TestDB database. And then I'm going to grant execute permissions on both of the stored procedures to public. Generally, this is not a good idea. In a real application, public is a role that's built into a database that you pretty much never want to use. But in this simple example, I just needed a role that made sure that anybody who connected to this database, who had enough access to the server instance in the database to be able to execute code, would have permission to run these stored procedures. Okay, so I'll go ahead and grant those execute permissions, because whoever executes a stored procedure has to have execute permissions. So I've covered that base. Okay, so now I'm going to create a certificate. So it's going to be encrypted by password. You can also create certificates that are protected automatically by a database master password, but that requires a little bit more setup, and I want to keep things simple. And subject is just some text to identify the certificate. Oops. Don't want to move that. My mouse skills are suffering today. Okay, so now we have that certificate, again within the TestDB database. And now I'm going to create a user from the certificate. So this new user within the database is not going to be associated with a login, but it's going to be associated with that certificate that I just created. So I'll execute that code. Okay. And to that user, I want to assign select permissions on that test table. So I'll go ahead and execute that code. Okay, so stepping back for just a moment, what I've done is I have a table. I've created a certificate associated with the user, and I've assigned select permissions on that table to the certificate user, which is associated with this certificate. So the last step here is to now add the signature to this stored procedure. Again, remember I created 2 stored procedures. One's unsigned, and now I'm going to sign this stored procedure. And I'm going to sign it with the certificate that I created, my certificate, and I'm going to assign a password. Okay, so I'll execute that. So that's all of the steps that I need to do. Now I have a procedure that is signed with the certificate associated with the user that has permissions on the underlying table. Okay, so let's see this in action. So now what I'm going to do is I'm going to change the execute context under which I'm running Management Studio. I'm currently logged in right now. All of the code that I've been executing so far, I'm logged in as a system admin within this instance of SQL Server. So I have complete omnipotent powers over every object within this instance of SQL Server. By executing this code, I'm going to switch my execution context to test login, which has no permissions whatsoever, except that it does have permission to access the database. Can't do anything with the objects, but it has access to the database. So I'll go ahead and change that execution context. So I no longer have sysadmin powers within this instance of SQL Server. Now I'll attempt to run that stored procedure that is unsigned. I'll execute that, and I get the message, the select permission was denied on object test table, database test DB, schema DBO. So because I assigned execute permission to the public role, I have permission to execute the stored procedure. Because there's a broken ownership chain, SQL Server also checks and makes sure that test login, the user that I'm currently executing code as, has permissions on the underlying table. But that user, who's me at the moment, does not have those permissions. So I can't execute the code that's contained within the body of that stored procedure. But now I'll try to execute the stored procedure that I signed. And again, has a certificate that's associated with the user, and the certificate has permissions on that underlying table. And so I'm able to execute a select statement against that table. All right, so when I'm done, I also want to revert so that I once again have permissions, my sysadmin permissions, within this instance of SQL Server.